Welcome to our video on nuclear energy. In this video we will be discussing the basics of how nuclear energy is generated, its advantages and disadvantages, and its future. Whether you are a student or just curious about nuclear energy, this video will provide you with a comprehensive overview of this important energy source. Let's get started. Nuclear energy is a form of energy that comes from the nucleus, or core, of atoms. Nuclear energy can be produced by splitting or fusing the nuclei of certain atoms, such as uranium or hydrogen. In this video, we will focus on nuclear fission, which is the process of splitting the nucleus of an atom into smaller parts. Nuclear power stations are facilities that use nuclear fission to generate electricity. They consist of several components, such as nuclear reactors, cooling systems, turbines, generators, and control rooms. Nuclear reactors are where the nuclear fission takes place. They contain fuel rods made of enriched uranium, which are arranged in a core surrounded by water or another coolant. The fuel rods are bombarded by neutrons, which cause some of the uranium atoms to split and release more neutrons and energy. This creates a chain reaction that can be controlled by inserting or removing control rods made of materials that absorb neutrons. The energy released by the fission heats up the coolant, which is pumped to a heat exchanger where it transfers its heat to another fluid, usually water. The heated water turns into steam, which drives a turbine connected to a generator that produces electricity. The steam is then condensed back into water and returned to the heat exchanger, while the coolant is cooled down and sent back to the reactor. The control room is where the operators monitor and regulate the operation of the power station. Nuclear reactions are changes in the structure or composition of atomic nuclei that result in the release or absorption of energy. Nuclear fission is one type of nuclear reaction that involves splitting a heavy nucleus into two or more lighter nuclei and releasing energy and neutrons. Nuclear fission can also be classified as fast or slow, depending on the speed of the neutrons involved. Fast fission occurs when high-energy neutrons cause fission in any type of uranium nucleus, while slow fission occurs when low-energy neutrons cause fission only in certain isotopes of uranium, such as uranium-235. Slow fission is more common and efficient for nuclear power generation, as it allows a sustained and controlled chain reaction. Nuclear power is a technology of energy production that uses nuclear fission to generate electricity. Nuclear power has several advantages and disadvantages compared to other sources of energy, such as fossil fuels or renewable energy. Some of the advantages are that nuclear power does not emit greenhouse gases or air pollutants that contribute to global warming or acid rain. That nuclear power has a high energy density and can provide a large amount of electricity from a small amount of fuel. And that nuclear power is reliable and can operate continuously without depending on weather conditions or natural resources. Some of the disadvantages are that nuclear power poses safety and security risks due to the possibility of accidents, sabotage or terrorism. That nuclear power produces radioactive waste that requires careful management and disposal. And that nuclear power is expensive and complex to build and operate. As of 2020, there were 440 operational nuclear reactors in 31 countries, providing about 10% of the world's electricity. The United States had the most reactors, 95, and produced the most nuclear energy, 809 TWh, followed by France, 56 reactors and 382 TWh, and China, 47 reactors and 348 TWh. France had the highest share of nuclear energy in its electricity mix, 70%, followed by Slovakia, 55%, and Ukraine, 53%. Some countries have plans to expand their nuclear capacity, such as China, India and Russia, while some countries have plans to phase out their nuclear power, such as Germany, Belgium and Switzerland. The future of nuclear power is uncertain and depends on many factors, such as technological innovation, economic competitiveness, environmental impact and social acceptance. Thanks for watching. Don't forget to like, comment and subscribe for more videos like this one. See you in the next one. Welcome to our video on nuclear energy. In this video,